Hello, everyone. My name is Haibing Zheng from Zhejiang University of Technology. The paper I will be presenting today is titled CertPri, Certifiable Prioritization for Deep Neural Networks by Movement Cost in Feature Space. The first is the background. Deep neural networks find applications in areas such as CV, NLP, and SE. However, they share vulnerabilities related to quality and reliability that can lead to serious consequences. A stark example about Tesla Model S is occurred in 2016 in Florida, USA, which draws widespread attention to these vulnerabilities. Researchers have focused on improving DNN-based software quality assurance, with the standout strategy being test input prioritization. This method involves sorting test inputs to quickly detect issues like misclassification within time and manual annotation limits. These methods include coverage-based, surprise-based, confidence-based, and mutation-based techniques. Although these methods have made significant progress, several concerns remain. The first is lack empirical formal guarantees, rendering them vulnerable to malicious attacks. The second is prioritization effectiveness and efficiency remain challenging. The third is generalization issue. Therefore, we set our object as follows. The first is integrating formal guarantees, but malicious continuity assumption. The second is enhancing effectiveness without degrading efficiency. The third is extending the applicability of prioritization through gradient estimation. Before the CertPri, we introduce the preliminary concepts. Here, we introduce two definitions: inversely perturbated test input, the minimum inverse perturbation and its lower bound. We also provide a comprehensive list of notation definitions. CertPri leverages certifiability to enhance prioritization significantly. To understand CertPri's principles better, let's kick off with an example. We compute the movement cost for 5,000 image test inputs on a pre-trained VGG model. Initially, we group these inputs into 10 categories by the original prediction probabilities, and then evaluate the costs of moving to the position with higher probability. Our analysis highlights a significant cost difference between correctly and incorrectly predicted inputs. We offer a technical overview of CertPri. In step A, we investigate the movement process of test inputs in forward propagation. As an illustration, we visualize the DNN-based distribution of test inputs in the feature space for a classifier utilizing a 3 hidden layer FCN and on the mainest dataset. We can draw two impressive conclusions. Most test inputs directional approach the correct class. The movement of these bug-revealing inputs in the forward propagation are directionless. Then we analyze the movement cost of correctly and incorrectly predicted test inputs based on the inverse perturbation, as shown in the figure. Correctly predicted inputs require high movement cost to reach their class centers. It's due to that correctly predicted inputs contain high feature purity, which keeps them stable in feature space. The incorrectly predicted inputs only require a low movement cost to reach the class center. It's due to the feature purity of the corresponding class have been improved. Then we give the formal guarantees for movement cost in the step B. Based on the Lipschitz continuity, we provide a formal guarantee for the lower bound of the inverse perturbation. The complete proof can be found online. Then in step C, we show how to obtain movement cost estimation using generalized extreme value theory. We plot curves of probability density function and its cumulative distribution function for different extreme value distributions. We find that there is a finite right endpoint in Weibull distribution, which limits the upper bound. Thus, we can adopt the Weibull to describe the gradient norm distribution. Finally, we compute the lower bound value of each test input, and then prioritize them according to their lower bound values. The experiments are introduced next. We evaluate CertPri across 5 data model pairs. We set up 3 training scenarios and 2 prioritization scenarios. Here are the metrics we used. We evaluate CertPri by answering 5 questions. The first is about if effective is CertPri. In terms of overall effectiveness, CertPri finds a better permutation of test inputs than baselines. We calculate p-value of t-test for CertPri. It shows a stable effect. In various data forms, it outperforms all baselines on 6 data forms, especially for unstructured data. In various data types, CertPri largely outperforms all baselines against adaptive attacks, which approaching prima against the adversarial attacks. In various training scenarios, it outperforms deep training and shows competitive performance with prima. In various prioritization scenarios, CertPri largely outperforms all baselines, which is beneficial to identify bug-revealing inputs in software engineering testing with privacy requirements. We can summarize and answer that CertPri outperforms baselines in 2 aspects in terms of effectiveness. The second question is how efficient. CertPri is more efficient than mutation-based methods and is competitive with confidence-based methods. We can answer that it is efficient in prioritization speed. Next, how robust is CertPri against adaptive attacks? In all cases, CertPri always performs the most robust prioritization results against various attacks. In utility of robustness, CertPri is not only immune to various adaptive attacks, but also facilitates the robustness of baselines through weighted combinations. We can answer that CertPri largely outperforms baselines in terms of robust prioritization. The first is how generic is CertPri. It always outperforms all baselines against various dimensions in terms of all average gene IW values. According to the figure, we can conclude as follows. The last question, can CertPri guide the retraining of DNNs? The answer is yes. We can conclude that CertPri guides DNNs retraining with only first 1% or 5% prioritized test inputs. In summary, we introduced CertPri, a certifiable prioritization technique for identifying bug-revealing test input. CertPri offers formal robustness guarantees for movement cost, enhancing its effectiveness in identifying malicious inputs. Thanks for your attention.